Hey guys, Light here for the fourth installment of Gravitime theory. We're making so much progress. I'm glad you're still here. In this video and in this Gadanken experiment, I'm going to show you how black holes are actually spikes in causality rather than holes. The uh, reason we've classified them as holes is because they, like any other hole, they have a tendency to gobble things up, right? We see things entering these realms. We've taken photographs of the outside of them uh, using some really incredible work and with radio telescopes. Uh, but calling them a hole is a huge misnomer. There's nothing hole-like about these structures in our universe, and a more accurate name would either be a black spike or a black pillar. I like the term spike better because it has a more better description about its curvature. Um, but the other thing about it is that when I say it's a spike into the fourth dimension, that means it goes on infinitely in a three-dimensional space. And any infinite objects in three-dimensional space from a three-dimensional perspective are going to appear as something else. And so to us, to three-dimensional physics, it looks and operates like a hole. But it is not a hole. It is the most extreme, most accelerated part of our three-dimensional system, and it is actually also the bound to our three-dimensional system. One of the reasons I've decided to publish my findings is the James Webb Telescope has been just releasing an absolute torrent of uh, early results from these deep redshifts that defy all expectations of that model. The previous model assumed that there would be these giant POP3 stars there that we would see that had low metallicity, and that the expectation is that the evolution of the universe was this very gradual evolution from hydrogen into helium, and then slowly through recycling stars we gained metals. And in order for gravitime theory to represent what we're seeing, the black holes have to be there, aka black spikes have to be there from the very beginning. And there's another big problem that this solves in the early stages of our universe. There's a period that they have shown that they call inflation, where as the universe cooled, all of a sudden, outer space goes through this insane transformation where, in order for what they're seeing to be true, the universe had to grow in size by something like 32 orders of magnitude. I might have that number wrong off the top of my head, but it's it's a it's an impossibly large number. It's an impossible amount of expansion according to our current models. And uh, I'm going to circle back to the early formation of our universe in the next video. I'm going to do an analogy with a two-dimensional black hole into a three-dimensional phase transition. Um, but just for now, I would like you to know that at the very beginning, there's a time period, and we have evidence for baryonic acoustic oscillations in the early quark gluon plasma of the universe before it cooled enough for matter to exist. And these baryonic acoustic oscillations, according to my model, what I believe is that they are actually the first black spikes that form in the universe. And immediately after that, the inflation that happens that we see is the result of three-dimensional space literally coming into existence as the bound is created. Without the bound, an infinite system cannot exist. Once the bound comes into existence for an infinite system, it's going to appear to just go from zero to everything. Because there is no timeline, there is no measurement, there is no capacity to even have gravity at that point. And once those first spikes occur, now we have the four-dimensional bound to our three-dimensional space. Inflation happens, the universe expands dramatically. There's all of these, the early formation of these early galaxies occur. We're seeing these very mature galaxies, only 400 million, 500 million years away from our estimation of the age of the universe. And in order for a galaxy to be that mature that quickly, it had to have a black spike at the center of it from the beginning. And as we're seeing all large galaxies, most of them, we're seeing that they have uh, supermassive black spikes at the center of them. And that's actually the whole reason these galaxies can exist at all. According to standard gravitation, the mass in those systems shouldn't hold them together. They should be flying apart. But they're not. They're fairly stable. They're moving towards each other. They're moving away from each other. In gravitime theory, these spikes in our causality wind up all connecting to each other in a superposition in 4 dimensions. And they fall into what we would consider to be a timeless void. AKA, they can no longer progress through causality, but our universe can actually never catch up to them. The matter that falls into these systems is accelerated beyond the speed of light. So relativistically, it stops existing in our three-dimensional space entirely. Its gravitime metric goes to infinity. It turns into this giant spike in causality. These spikes all connect to each other in a four-dimensional superposition. Relativistically, they're not moving at all from the perspective of the inside of these systems. From their perspective, they may as well be stationary because the Higgs field is completely collapsed. And gravity and time are interlinked. They are the same thing. So you no longer have gravity or time in one of these black spikes as it spikes into infinity. It never actually reaches an end. There is no singularity. As far as our three-dimensional space is concerned, there's actually the only record that our three-dimensional space can have is that there is still matter in that realm. And everything that we're seeing as far as these large black spikes are concerned, the reason they hold these giant structures in place because they're they're operating more like an inverse whirlpool, except the whirlpool isn't just going in one direction. You can't say it's a hole. Even a spike is technically wrong because it's going in every direction. But the Higgs field is still trying to, do its thing. So the communication layer that the Higgs field is performing just assumes that it doesn't that matter is still there. So it treats this realm as though the matter is there, but there's no signal coming back. But the Higgs field, it doesn't have, it's not a two-way street. It just sends. It's not listening, it just sends. And when it sends, it gets that information through entanglement. And all of that information that the Higgs field receives is basically to itself. That also seems counterintuitive, but the reason this is relevant is because to the Higgs field, a black hole is just a massive object. Even though it doesn't technically exist in our 3D space anymore, the shadow of the 3D matter and space that has fallen into that realm is still pulling relativistically on our 3D space. So this spike in causality just pierces through into a four-dimensional superposition. Now, I don't think our universe has actually any four-dimensional space characteristics available to it, but these four-dimensional objects can exist here because they no longer have time. They no longer have gravitime. They've been accelerated beyond the speed of light. They're going to be effectively, like from our perspective, they're going to be stuck there until the end of our three-dimensional universe. And so for this Gedanken experiment, what I really want to do is I want you to think about an infinite spike in three-dimensional space. I'm going to show you a very rudimentary three-dimensional estimation of this. I know I said it was a huge faux pas to try to represent four-dimensional objects in three dimensions, but unfortunately for this concept to really drive home, I need you to see how it goes in every direction. And because it's going in every direction, it can connect to anything else, any other one of these objects in our universe. And the great attractor that is also another huge question is very likely the center point of these connections in our local group, and where these objects have a tendency to go even beyond the Higgs mechanism, where they're trying to pull themselves towards each other in the fourth dimension. That's why we see these black hole mergers. That's why we see galaxies merging. It's not just gravity, because gravity isn't real. These four-dimensional objects are all pulling towards each other, while simultaneously pulling into them, accelerating 3D space, accelerating 3D matter, and the space and matter that falls into them will eventually become four-dimensional space and matter at the end of our 3D universe. So imagine one of these impossibly long, infinitely long spikes at the center of our Milky Way. Falling into it at very close to the speed of light is just an endless supply of three-dimensional space. It's going in every direction away from this, it's going into this, and the rate at which all black spikes are pulling space and matter into them, behind it or around it, it causes the three-dimensional space to appear as though it's expanding, right? So we have all of this space, all of this matter going into this funnel. We'll just say it's an upward funnel for this example. It's going into this upward funnel, and as that happens, it's not just happening in our galaxy, it's happening in all galaxies. Everywhere there's a supermassive black hole, we see this phenomenon. And so the expansion of the universe, the Hubble tension that they're seeing, where earlier in the universe we can tell by looking at old light versus new light that it was expanding slower earlier, and that expansion is accelerating. But the universe isn't actually expanding, it's contracting. But as it contracts, every single one of these black spikes is pulling three-dimensional space into it. Now, in our universe, three-dimensional space is an infinite system. So if you have an infinite supply of three-dimensional space, then pulling it into another system shouldn't matter. But the reason it matters here is that so much volume, such an incredible volume. You have to take the radius of every black spike in the known universe and then apply that to the entire universe. Now again, I've said three-dimensional space is infinite, but I actually don't think that three-dimensional matter is infinite. I think that there is a finite amount of three-dimensional matter, that it is a mappable system. To the size and scope that that might be, it's very hard to make any kind of conjecture because we can't see it. But these black spikes, as they funnel matter and space into them at the same time, the rate at which they are pulling space into them accelerates by fact of the total amount of matter that has gone into any of those objects in our entire universe. So the more matter we have inside of a black spike globally, universally, right? The harder, the more, the faster space is pulled into these systems. Now, I think we obviously have a while before this entire pattern comes to fruition. However, the final destination for all matter in the universe is the inside of one of these black spikes. And they're going to continue to pull each other towards each other in the fourth dimension while they continue to pull all three-dimensional matter and space into them. As soon as all of the three-dimensional matter has been drained into these systems, three-dimensional space itself will go through the opposite of inflation. Every black spike in the universe will merge, and from that merger, you will form a four-dimensional white hole. I'm going to explain that in the next video by showing how our universe was preempted by a two-dimensional universe that went through the very similar uh, evolution and acceleration. And at the beginning of our three-dimensional universe was actually a two-dimensional white hole. I hope you understand what I'm saying here. Sometimes I feel like I've gone all the way off the deep end, but you know, this is all I have. This is what my brain does. This is all I can think about. I asked too many questions. But it's the best way for me to live, I think. Um, I really do appreciate your time. I appreciate you listening. I hope what I'm saying is landing. I hope the takeaway you get from this video is the understanding that just because we see our our three-dimensional space expanding doesn't mean our universe is expanding. It means the three-dimensional space we're looking through is being stretched. By causality itself. It's an infinite system, there's an infinite amount of space, but the rate at which it's moving changes what we're seeing. And it's going to continue to accelerate until the end of our three-dimensional universe. So I hope you will like and follow and subscribe and all that shit. I'm really excited for the next one because I get to show you uh, the totality of what this dimensional hierarchy does and how it explains the beginning of our universe and why all of this is important to our place in it.